Hey everyone. So we're gonna go ahead. I've got another video today, and then we're gonna have a last one on Friday for 4.1. So we're just gonna add one kind of layer of complexity onto what we were doing yesterday. So yesterday we were saying, okay, I've got my slope, I've got my y-intercept. Now we've got to go back and do a little bit of math before we get to the slope. All right. So we're on page 99 here in our student journal. And so the first type of equation is giving us these little lines, and we have to figure out what the slope is here. So remember, don't just think of the slope as, okay, it's some random value. Remember what that means in the context of one of these graphs. All right, so remember slope, it's our rate of change, it's the angle of the line. We always want to think of rise over run. All right, how far is it moving up or down over how far is it going side to side. Okay, so that's going to be your change in y over your change in x. All right, so when we have a graph like this, we do have an equation we can use to find this, but I think it's the easier way to figure this out is going to be to look at the graph and think, okay, what is my change in my y value? How much am I moving up or down? And then what is the change in my x value? So the way I like to look at slope, I always like to think, okay, I want to go from this point to this. I want to go from left to right. All right, because if I have to deal with a negative value, I always want to think of that on my y. I just think it's easier when the negative value is on top. I think a lot of people get confused that they would start on the right and go left. So I would always on all these go from left to right. Okay, that's how I think of it. Okay, so in this one, I'm thinking if I want to, okay, my change in y, I'm moving down 1, 2, 3, 4. Okay, I move down 4. And my change in x, my run, I go right 1. So my slope here is -4. So let's plug this into my slope-intercept form. My y equals mx plus b. Okay, so my y is equal to -4 times x. Then my b is my y-intercept. It labeled it for me right here, 0, -1. That -1 is my b. So I've got -4x minus 1. All right, I'm not going to do every one of these. Let me look over here at number 12. All right, same deal. I want to look at my slope. Okay, always go from left here to right. Okay, always this direction. All right, so my change in y, I'm thinking, okay, am I moving up or down? I'm moving down, so that's going to be a negative. Okay, I'm moving down 1, 2, 3. And then I'm moving over. My run is 1, 2, 3, 4. Okay, that's already simplified, so that's my m. So I have y is equal to -3/4 x. And then don't get tripped up here. Don't look at this x-intercept here and think, oh, it's 4. No, you're always looking at the y-intercept where it's crossing that y-axis. So my b value here is +3. Right? And just because I just realized both of these slopes were negative, let's look at a positive slope over here. Okay, I'm thinking from left to right. Okay, so I'm thinking, what's my rise over run? And I've got, okay, from here to here, I'm going up 1, and then over 1, 2. Okay, so when I move up, I have a positive slope. If I'm moving down, like in this problem over here, I have a negative. Okay, so this one would be y is equal to 1/2 x, and then that b would be minus 2. Okay, so it's easy enough when we have the actual graphs. Let's go over here. We're on page 100. All right, and we're going to look at what if we don't have the actual graph. I'm going to do kind of a refresher on actually finding the slope. Okay, let's see if we can remember. Remember, we had that y2 minus y1 over x2 minus x1, this little equation that we can do to find our slope. Okay, so it's adding one more little step where we have to actually go in and find our slope. Okay, so the way I like to do this is I like to say, okay, this is my point 1, this is my point 2. It doesn't matter which is which, but labeling them kind of helps me to make sure I'm not flip-flopping which points are which. Okay, you want to keep it consistent. Right, so this formula means, okay, I've got my y2 and my y1, I've got my x2 and my x1. Okay, so my y2, that's the y in my second point. If this is hard for you to keep track of all these points, sometimes it also helps to just write out that x and then y if you're like me and sometimes you flip-flop the x and the y in your head. Okay, so y2 is the y in my second point, so that's 4 minus y1, so minus right here, that negative 4. Okay, y1 is the y in my 1 point. Then the same thing here over with x. I've got x2 minus x1, so the x in my 2 point is 8, minus the x in my 1 point is 0. Okay, so 4 minus a negative 4, that's 4 plus 4. 8 minus 0 is 8. I get 8 over 8, which I know just simplifies to 1. Okay, so I know my slope is 1. And I think in all of these it just gives you, yes, it gives you that y-intercept. Okay, your y-intercept is always going to be in that 0, y, okay, some number there for y. Okay, so in all of these it gives you that y-intercept, so you can say, okay, I know my my slope is 1, so I've got y is equal to 1x. Right? And my b is over here, this negative 4, so 1x minus 4, which I can just simplify here to x minus 4. All right, I want to do just one more because I think sometimes this slope thing, until we get the hang of it, sometimes it's a little bit hard to write out these different equations. So I'm actually going to look at number 17. All right, so we've got, I'm going to call this my 1 and this my 2. Just as a reminder, it doesn't matter which point you decide is 1 and which one you decide is 2. As long as you keep it consistent as you're doing the problem, you're going to end up with the same answer either way. Okay, so y2, the y in my 2 point is 8, minus y1, so minus 0. And then I have x2 minus x1, so the x in my 2 point is 0, minus that x1, the x in my 1 point is 8. Okay, so 8 minus 0 is 8, and 0 minus 8 is negative 8. Okay, similar to the last one, but now instead of 1, it's negative 1. Right? So now I know that my slope is negative 1, my m is negative 1, and if I'm looking at these two, I can see, okay, I have a 0 here as my y, I have a 0 here as my x. If I'm trying to think, okay, which one of this is my actual b value, which one of this is my y-intercept, it's always in this 0, then y. So this point right here is my y-intercept. I guess it doesn't really matter in this one because they're both 8, but just in the future, if it tries to trip you up again and give you both intercepts, you're looking for the one in that 0 number format. Okay, so your m is -1 and your b is +8, so y is equal to -1x plus 8. And then let's go ahead and simplify that -1 just here to -x plus 8. Okay, and then we can move on. I don't want to get into this function notation stuff. We'll do that on Friday, and then we will be all done with 4.1. And I will see you guys later.